two rules we have used here. You see this one, okay. If exponential here constant times 6 is there, then you can take it. Okay, directly you can get this solution. Okay. And here, if there is a product of the exponential and algebraic function, then this is how you proceed. This formula we use by using this binomial expansor. Now if you see here f of a not equals to 0. Okay. But here f of what happens if f of a equals to 0? Which formula to use? So here this first one, this equation, these two formulas which we have discussed, the first one cannot be used. Okay. Then what we do here is, you see, f of a equals to 0. So a is a root of this f of t. So you can write this f of t as, since it's a root, d minus a into phi of d. This is how you can write. Okay, so we will split this one and we use both the functions, the second function now. Okay, what we do here, suppose here we have 1 by f of t e power ax. Okay, so we will rewrite this one in terms of phi of t, d minus a into phi of d. Now phi of d, if a is a root, okay, and phi of d is of this one, and phi of a not equals to 0 now. Okay, so d minus a is a factor of f of t, so that's why we will write it like this. Okay, so now what we can do, this phi of d, we can use the first formula here. If phi of a not equals to 0, then this one. We have already taken out this factor. If a is multiple times, that also we can see. If it's this power r, you can see. So here you see the first formula, you can see use phi of d here. Okay, so e of x by phi of a, 1 by d minus a, then we have e for ax by phi of a. And so this is now a constant, you can take it to this side. Okay, 1 by phi of a and 1 by d minus a e power x. Now we will use the second formula. Here what we do, this one we will consider the algebraic function, we will consider as 1, that is x power 0. Now you can take e of ax to this side, okay, and this d will be replaced by d plus a. So e of ax, so we are done with this part. Okay, now d will be replaced by d plus a minus a, and here we have 1. Okay, got it? So 1 by d is the inverse operator, so we will do the integration. Okay, 1 by d1, if you do the integration, you will be getting x. Okay. So here e power ax by phi of a, and this will be x, because 1 by d of 1 is nothing but the integral. Inverse operator of the differentiation is 1 dot dx is x. Okay, so here we have the answer. Okay. Similarly, if the root a occurs r times, see, so here we took if the root a occurs once. If the root a occurs r times, then this f of d, you can write it as d minus a for r into phi of d. Okay, this is how you can say. So 1 by f of d e power ax. So this one will be d minus a power r phi of d e power ax. Okay, so here, and now the same process, phi of d will be replaced by a and d minus ar. Similar process, 1 by, you have the process there here, phi of a. we'll make it 1, and d will be replaced by d plus a. This will come here. Similarly as we did the previous one. So d will be now replaced by d plus a. Okay. And this is for r. So we have to integrate this one r times. So if you integrate 1, it will be x by r factorial will come. Okay. X by r factorial, you're integrating r times. So 1. So you have x for r by r factorial. Okay. So this is how you will do. Is it clear? So we will do one problem. Okay. And you can see. So find the particular integral. So I'm discussing the particular integral because we have done that complementary function part within the linear homogeneous equations. Okay. We will do also.
ଆମେ ଆପଣମାନଙ୍କ ପାଖକୁ ନେଇ ଆସିଛୁ ହରେକ ମାଲ 10 ପ୍ଲେଟ୍ 130 ଟଙ୍କା ଏବଂ 70 ଟଙ୍କାରେ ପାଇପାରିବେ ଷ୍ଟିଲ୍ ପିତ୍ତଳ ରସର ଜିନିଷ ଘରୋଇ ଉପକରଣ ଯେପରିକି ଷ୍ଟିଲ୍ ଟିଫିନ୍ 130 ଟଙ୍କା ଷ୍ଟିଲ୍ ଥାଳି 130 ଟଙ୍କା
Okay, you can see this one. So d minus 2 square. So y will be 1 by d minus 2 square e power 2x. Okay. See, if you put d equals to 2, it will 2 minus 2 becomes 0. Okay. So we cannot put that one. Okay. So if we put d equals to 2, denominator will be 0. So it's kind of undefined form we are getting. So we cannot see, do this one. So we will use the other part. Okay. So we cannot use this formula. Okay. Now y equals to 1 by d minus 2 square. So we will be using dot 1. Okay. E power 2x dot 1. Okay. And d will be replaced by d plus a. Like e power 2x vx form, the second formula. So d plus 2 minus 2 square 1. Now e power 2x, and we have this 1 by d square 1. So if you integrate 1 2 times, we are getting x square by 2. Okay, so this is what we are getting. Okay. So let me give you one. I try this one. Find the particular integral. Okay, so this is what. So find the particular integral.
Ma'am, e to the power 3x or only 3x?
Okay, e to the power 3x. Sorry. This is the regular one, okay? E to the power x into vx form.
Ma'am, we did this question yesterday.
We did this one.
Yes, ma'am. The last question.
Okay, d square plus 2 we have done. Okay. Then we will look at the sin x form, okay? Sin x, sin x and cos x, okay? So this one, again, okay, let me tell you the formula, okay? Thank you, thank you. Very nice. So another formula we will discuss. So here it is for the sine and cosine, okay? So 1 by f d square, if it is there, and sine x, then d square will be replaced by minus a square, okay? Minus a square, sine x. And this is not only this one, this also works for cosine. And only d square term, right? If you have d only, then d won't be replaced. Only d square. If you have dq, you can make it d square dot d, and in place of d square, you can put this minus a square. Okay. F of minus a square. Okay. And here the only thing we will make sure that f of minus a square is not equals to 0. Suppose we have only minus a square term and it is going to 0, then that there we cannot use. Like we did f of a not equals to 0 in the previous case. But when it will be a 0, then what we will do? Okay. So we will come to that. Okay. So first we will solve this one, then we will look at what happens when it becomes 0. So we have find the pi stands for the particular integral. So I have written here dq, but you can solve it. Okay, you can change it to the form e or x cos x plus sine 3x. And the pi of dq plus 1y equals to x cos x plus sine 3x. So find it. Find the solution.
Uncle.
dq plus 1 sine 3x. So this one will be e power x px form. So you take this e power x to this side, and here we have d will be replaced by d plus 1 q plus 1 cos x. And here d cube, we will write it d square into d. And d square will be replaced by minus 3 square. This one minus a square. So you open this bracket. Anyone done? D plus 1 cube. It will be d cube plus 3d square plus 3d plus 1 cos x. See, here we will be using minus 3 square, that is minus 9d plus 1 sine 3x. Okay, so this is how you do if you have the even odd powers of d cube. So here also d cube, we can write d square into d, and here we have minus 1, so we can make it minus 1d. Then here 3d square, if you put d square as minus 1, so this will be minus 3 plus 3d plus 1.
Ma'am, there will be another plus one in
Plus
the
two.
yes,
Yes,
ma'am.
ma'am.
Plus one, plus one, plus one. Yes, ma'am.
Plus 2. And here it is 1 minus 9d. So how we will proceed with 1 minus 9d? See, you can use this one. Okay. So 1 minus 9d sine 3x. Okay. Let me write this properly. And this one will be for x 1 by 2d minus 1. It will have the form 2d minus 1. This is 2d minus 1 cos x plus 1 by 1 minus 9d sine 3x. So what you can think now, what we will do? See, one thing you know, you can go for the binomial expansion. But binomial expansion, we will go for the algebraic function, because if you go for the higher derivatives, there we will get the 0. But if sine and cosine is there, they're infinite times differentiable. Okay, we will get the infinite series if you go for the binomial expansion. What else you can think of? Any idea, anyone? Any idea?
Taylor series.
Yes?
Ma'am, expansion.
What expansion? Which expansion?
Taylor's expansion.
Taylor's expansion. I told you, if cos x, if you do Taylor's expansion, 1 by 2d minus 1, we have to do binomial expansion, so you will get the infinite series. See, there is a easy one. Okay, here we are using d as the operator you have seen. Okay, so what we will do, we will simply multiply 2d plus 1 so that we will get d square in the denominator. And we can substitute this cos a. So here we will multiply 2d plus 1 and in the denominator also 2d plus 1. So we will have 4d square minus 1 cos x. Now you see in place of d square you can put minus a square, that is minus 1 here. Okay. And we are only left with the d in the upper parts, that means only once we have to differentiate. So here also you can do 1 plus 9d. So here we have 1 minus 81d square sine 3x. So this is one easy way you can do. So here e power x, so 2d plus
Excuse
1.
me, ma'am.
Yes.
Please repeat that part.
What I missed?
Please repeat that part.
See, like you do in the normal algebra process, okay, we multiply 2d plus 1 in the denominator and numerator, okay, so that we get d square term in the denominator. And you see, if you get d square in the denominator, you can replace this d square by minus a square, this cos ax. Are you getting? So our purpose is whenever cosine and sine is there, we will try to write down all the denominator terms in d square so that we can use our formula. Like here we did. See, the d square we replaced by minus 9. Here also we replaced by minus 1. So we will try to make the denominator term by d square so that we can get rid of it. Okay. So here cos x minus 1. 1 is there. So minus a square will be minus 1. Minus 1. Now cos x. Got it. Then 1 plus 9d. 1 minus 81. So here you have 3. So minus a square. 3 square is 9. Sine 3x. Got it? So this is minus 4 minus 5. You can make it minus 5. So 2d plus 1. Now if you add some cos x, 2 into differentiation d by dx of cos x. So d by dx of cos x is minus 2 sine x plus cos x. 1 is cos x. We multiply. Is it okay? Got it? Similarly, here we have 81 into minus 9. Okay. So you will be getting, this will be plus 1 plus 729. So that will be 1 by 730. Got it? 81 into 9 is 729 plus 1 minus minus plus. Now 1 plus 90, 1 into sine 3x is sine 3x. And 9 d is d by dx, so 9 cos x. Cos 3x. There will be one more 3. So it will be 27. Okay. 9 into 3 will be 27. So you can further simplify this one. Okay, how much you are getting, you see. Or you can write it like this. Okay, there is one minus sign, so you can adjust this one to sin x e power x by 5 to sin x minus cos x. And this will be, this part remains same. Only minus sign I have adjusted here. Sin 3x plus 27 cos 3x. Is it okay? How I done? Or any doubt with this? Any doubt?
No, ma'am.
Okay, so now we will move on to what happens when we have f of minus a squared 0. See, we use this formula for f of, we can use this formula whenever f of minus a square is not equals to 0. That denominator term is not going to 0, then we can use this formula. So now we will look at the situation where if f of minus a squared is 0, then the previous formula will not work. Okay, So we proceed, then we proceed in the following manner. We cannot use the formula. Okay, we proceed then in following manner. Okay, so what we do here, so we consider the equation. Let's see, 1 by d square plus a square. If you have here cosine or sine, you will replace it cos ax or sine x. This becomes minus a square and a square becomes 0. So denominator goes to 0. So instead of sine ax or cos ax, we simply consider e power I ax. You got it? So it's the by Euler's rule. Okay, e power I theta is cos theta plus I sine theta. You see, cos ax plus I sin x. So instead, if you have any cos x or sin x, instead of that we use this one I ax. Okay, now you see what will happen. The real part of the particular integral, we will solve this one, and the real part, because if you open this one, this is cos x plus I sin x divided by d square plus a square. So the real part will be giving you the pi for cos x, and the imaginary part of pi will give you pi for sin x. Okay. In place of original equation. Okay. So now real part of pi. We find the particular integral of this one. Okay, once you find the particular integral of this one, okay, from that we will consider the real part. Okay, the real part of the particular integral of x will be the pi for the cos x, because here cos x, pi for cos x. Okay, and the imaginary part of particular integral of e power I ax will be the pi for the sine x. Okay, so now we can proceed. Okay, if you want, you can see also. Let's see, let me show you. 1 by d square plus a square e power I ax. So here it is e power I ax. Okay, so if you put e power a square, okay, so we will not do that. We will factorize this one, d plus ia into d minus ia e power iax. Okay, because if you put ia here, it will be minus a square, right? I square is minus 1 a square, and it becomes 0. Instead of that, we will do this one. Okay, so now we will put this formula here, d plus ia. In d plus ia, you can substitute this one, 1 by ia plus ia. Okay, and d minus ia will remain. Okay. So here 1 by 2 multiply, then we have this one. Okay, so then again what we will do is this one, we will put it here 1. Okay, this is how we will consider. Okay, so now e power x into vx, that form we will consider. So in that place what happens? E power I ax, and here d plus ia. D will be replaced by d plus a, and this one will be there. So this ia gets cancelled, and we have e power I ax by 2 ia. So 1 by d, 1. So 1 by d, if you inverse of the differential operator is the integral, so x we will be getting. So x e power I x by 2IA. Okay. So if you want further, you can change it to this form. Okay. So we want the imaginary and the real part. So we will make I is in the denominator. So we will make it minus ix by 2a, and this e power ix we can write it as the cos ax plus I sin ax. Okay. And if you want this I, you can multiply. So it will be x by 2a minus I cos ax. This is minus I, so it will be sin ax minus I cos ax. So here the imaginary part and real part will, you can see. So here 1 by t square plus a square. If you have the sin ax, then it will be the imaginary part, you see. Imaginary part will be the pi for the sin ax. So here it will be x by 2a cos ax minus x by 2a cos ax. Okay. So if you want, you solve it for the e power ix, or you can directly use this formula also. Cos ax x by 2a sin ax. So this is the formula. If you want, you can directly use. Okay, if all the things are satisfied, you can directly use this formula. And you can write, we used to write this in this form.
Ma'am, this is a general solution without any conditions.
The condition is whenever you have minus f of minus a square becomes 0, we get this solution. So you can also write it this way, x by 2 integration of sin ax. Okay, and 1 by t
Ma'am, but we
square.
did not use that condition.
Which
Right?
condition?
Ma'am, that f of minus a square equals to 0, we didn't use that, right?
But that becomes, if it becomes 0 in the denominator, we are getting 0, you see. It is 0 only when then we use. If it's not 0, you can use
No,
this
ma'am, in the
regular one.
formula, in the derivation of the formula, we didn't use that fact.
What fact?
That f of minus a square is 0.
F of minus a square is 0, right? We didn't use, because f of minus a square is 0, then only we use this one. See, f of minus a square, if you put minus a denominator, becomes 0, so it becomes
Yes.
undefined. So that's why we proceed in this form. Whenever this happens, if not equals to 0, this formula you can do for the cos x and sin x.
Ma'am, can you explain the second step why we are breaking it? D square minus 1 d square plus 1.
See, even if what happens, you remember 1 by this d square plus a square e power ix. So what we used to do, this one is eix, and here in place of d, we substitute this coefficient of x. So ia square plus a square, what happens? The same, it is minus a square and a square, it becomes 0 in the denominator. Got it? Undefined form we are getting. So just to avoid that thing, we are proceeding in this manner. Got it? In the denominator, if you get 0, it's undefined. That's why we are proceeding in this manner. Got it?
Okay, ma'am. Yes, ma'am.
Even if you use e power ax form, we are getting 0 in the denominator. So to avoid this one, we are going in this form. Okay. So either you, if you don't remember, you proceed in this manner, or you can directly use this formula also. We are getting from this one. But if you integrate cos x, you will be getting minus 1 by a sin x, or sin x minus a, and 1 by a cos x. Okay, so this formula also you can use. If you want, you derive it. If you remember, you can use this one also. Got it? So find the pi of find the particular integral of cos 6. You can proceed in this form. एक छोटा सा लल्ला बालक जो कुछ कर सकता है वो और भी हम सकता है राम तुम मुझे वृंदावन अभी क्या अभी जाना बताओ चुपचाप तुम में से वृंदावन है उन्होंने अभी जाना वो तो इंसान के लिए ये तो इंसान को खाता है ना ठीक है वृंदावन इस फॉरेस्ट के अंदर है पर उसके सामने एक ऐसा वाला नागिन रहता है पर पहले वो कृष्णा को खाने चला था कृष्णा ने उसे कंट्रोल कर लिया कृष्णा ने उसे कंट्रोल कर लिया ठीक है तो वो मुझे भी कंट्रोल नहीं कर सकता तो जादू ही बात से कंट्रोल हो सकता नहीं मम्मी का मतलब I don't ever go book. Maybe we can get अभी तक मैं यहाँ क्यों नहीं आई? राधा तो हर वक्त So done the first one? Yes.
हमें x sin x by 2.
So first one is x sin x by 2. Both ways you can proceed. Okay, it's the easier one. So if you look at the first one.
Yeah.
So here we have d square plus 1. D square plus 1 cos 6. So if you put 1, it is going to be 0. Okay. So f of minus 1 square is making it 0. So either you can proceed in the previous forms or you can directly use this one. We have cos x form. So x by 2a. A is 1 here. So here x by 2, the integral of cos x. Cos x dx. Okay, so you can see it will be minus sin x. Okay, a is 1, so minus x sin x by sorry. मछली पकड़ने के लिए सही तरीका हमको बिल्कुल देंगे तो मछली तरीका दोस्तों पहले हमें ट्राई करना मुझे ये बोल शायद उन्हें पसंद आई आओ ने मेरा उंगली काट लिया कृष्णा अरे क्या हुआ just a plus sin x integration. Okay. So directly I have done. You can also proceed with by considering e power ix. Now the second one. So here y equals to 1 by d square plus 4 x sin x. Anyone done this one? So see, look at the formulas. I told you about the sin x or cos x or e power x or here we have x into e power x. These are the 4 types of functions I told you how to deal with it. So you have to look at all these formulas and you have to find. Okay. So here, since x sin x term I didn't tell you. Okay. So we will try. We know for the x, that means bx e power ax. This form we know. So we will try to convert this one. We can do this one, right? D square plus 4 x, and instead of sin x we will consider e power ix. Okay, so since e power ix will be cos x plus I sin x, so we will solve it for the e power ix, and we will consider the imaginary part of the pi, and we will have this one. Okay, so here just write out d square plus 4 e power ix into x. Okay, so e power ix, if you take it to that side, what we are left with? E power ix. So here I, a is I. So d will be replaced by d by I. So e power ix. So d will be replaced by d plus I square plus 4 into x. So e power ix d plus I square will be minus 1.
Ma'am, are you finding the PI?
Yes, I'm finding the pi. What happened?
No.
Pi, right? Pi means particular integral. We're solving for the particular integral. See, complementary function is there, but since you already know, I'm only doing this for the particular integral. Is there anything wrong?
Oh, ma'am, I got. No. Sorry.
Yes? Okay. So you know how to do for the algebraic function. So we will take common 4. Okay. So here actually we will have minus 1. So minus 1 plus 4 is 3. So e power ix by 3. So here we have 1 plus 3. If you take common 1 plus d square plus 2id by 3. Okay, this will be there in the denominator. Okay, so now we will go for the binomial expansion as I told you. For the algebraic function, we go for the binomial expansion. 1 plus, we will write 2id plus d square by 3. You see, we have only one power of x, so only it will work for the d. For the d2 or the higher powers, it will go to the 0. It's a differential operator, only once you can differentiate. Okay, once differentiate, you will be getting 1. Second differentiation will go give you 0. So 1 plus 2id plus d square by 3 minus, right? This is minus. Plus this term will be the square, and it will be giving you the square term, the higher degree, square cube. And for those terms, we have the 0. Only for this first term we have, okay. So e power ix by 3. So 1 into x is x minus 2I by 3. Okay, d. So once you differentiate x, we will be getting 1. D squared, 2 times you differentiate 0. And this will all higher powers of d or d2. Okay, so this is what we have. Okay. So here you see what you are getting. X minus 2I by 3. So we will so 1 by 9 3x minus 2y, and this e power ix will be sin x plus, sorry, cos x plus I sin x. Cos x plus I sin x. What is it? Now here. So here the pi we have sin x, so the imaginary part of pi of e power ix will be the pi for sin x. Okay. Okay. So the imaginary part here. What will be the imaginary part there? That also you have to find. So 1 by 9 3x I sin x. So this is 1 by 9 3x sin x is one term. And here 1 by 9 minus 2y cos x. Okay. So minus 2 by 9 cos x. So we can take this 9 out. I think 3x sin x minus 2 cos x. This is the imaginary part. So the imaginary part on pi. So this one, so this is your answer. Okay. The required particular integral. Whatever you have, you look at it and try. So this is the required particular integral. Okay. Now there is one more formula left. Okay, this is the last one. And with this 5 formula, you have to look at the differential equations of second order and find. Okay. So here, this one. If b is a function of x, well, yes. So how to this one? I will say. Okay, so here b means b of x. So if you have the function v and it is of the form x into vx form, so this is how you will go x into 1 by f of t px. Okay. Then d by, that means it's the differentiation of d of 1 by f of t into v.
Ma'am, what is the meaning of d by dd of 1 by
That is, it's a differentiation. Okay.
differentiation of FD?
Yes, 1 by f of t. This one. Okay. Kind of, for example, you see you have d by, suppose we have d square. So what, if you differentiate it, what you will be getting? Like you do it with respect to x. Okay. Derivation is there. Okay. But here, if you differentiate it, what you will be getting? Minus 2 by t cube. Isn't it? You will be getting this?
Yes, ma'am.
Like you do 1 by x squared. It's like d by dx of 1 by x squared. The process remains same. Okay, this is how. So see one example we will do and it will be clear. So the same, you can try this one. Okay, this x sin x we did the last example, right? That also you can try here. X sin x d square plus 4 by y. X sin x. Okay. So here x sin x. So we will try this formula here. Okay. So you see, for y, 1 by d square plus 4 x sin x. Now this formula you can use. Okay, like it is 1 by f of d x into v of x. Okay. So what you will be using first x into whatever I have written, x into 1 by d square plus 4 sin x. Okay. This formula x into 1 by f of d dx plus the differentiation of 1 by f of t is d square plus 4. Okay, and into x sin x I think. Only dx, so sin x. So here what we will do, 1 by d square plus 4. You can put minus 1 a d square place of minus a square. A is 1, so minus 1 square minus 1 plus 4. Minus 1 plus 4. Plus here if you differentiate this one, what we are getting is d square 1 by x. So if you differentiate, you will be getting minus 1 by x square. So here d square is there, x square plus 4 kind of. So you will be getting 2x minus 2x. So minus 2d by d square plus 4 square. Got it? So here this is minus 3x by 3 sin x, first part. Okay. And here d square plus 4 square, so 2d, and we can put in d square, it will be minus a square, so minus 1 plus 4 square sin x. So 2d will work on, okay, d is the differential operator. Okay, so you see which one this will be. 1 minus 1 plus 4 is 3, 3 square is
2 by 9 cos x. 2 by
2.
9.
Which one?
Minus
3 by
2 by 9
9.
cos
Okay,
x.
okay, I made it 2. 2 by 9, and if you differentiate sin x, you will be getting cos x. So this is what we are getting. Now you compare the answer x by 3 sin x minus 2 by 9. So we took common, I think, 1 by 9. Then 3x sin x minus 2 cos x. The answer, you can compare the answer since we have solved it in the previous one. So 1 by 9, 3x sin x minus 2 cos x. Okay. So we are getting this. Okay. This is also one of the way required PI. Get it? So we have discussed almost all the formulas. Okay. So you can try the exercise. I think some 5.4 I told you. So that you try from the generator. Okay. Only variation of parameters left, but many questions you can solve from here. Okay. So solve it and practice it. Okay, so now we have done the formula, so you practice it. Okay. So once you practice, it's easier. Only simple practices. Okay, you just practice little bit, and you will get to know. Like directly, you can use the formula. It's very easy. So it's time now. I'm ending. So I'm ending the class.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.